Hey there, welcome back to Coding at Home. Hey there, welcome back to Coding at Home with the Code Hub. We are going to go play with some more augmented reality stuff today. We spent a little bit of time going back to Swift yesterday and Swift Playground, so you may have had a little bit of a rough re-entry. It's always that way when you switch to another technology and then you come back to one that you've already learned. It may take a little while to get the gears spinning again. I hope you're getting as excited about WWDC as I am. Hopefully you've been going through the developer app that is now on macOS, on the iPad, and on the iPhone, because they've been posting lots of videos. You can go through old videos, and some of those are even still relevant. There's some great interface builder videos from 2017 that are still stand today, because they talk about a lot of ways to lay out your application so that it resizes for different devices, like a phone or a pad. So well worth kind of exploring and just having a browse around. They're really well presented sessions, and they introduce you to a lot of new technologies that you might not have discovered otherwise. Speaking of videos, we posted a video yesterday on the Code Hub channel. This is the plug to like and subscribe, but called Getting Started with Xcode. So if you are ready to make that next leap, so we've been doing all of our coding, all of our work on iPad so far. If you're ready to make the leap to working on apps that you would put on a phone or on an iPad or on TV, Apple TV, or a watch, you need Xcode for that, and you need a Mac, whether it's an iMac or a laptop, and Xcode. That session will walk you through building a small sample app. It's not very exciting, but it shows you some of the cool features of Xcode and teaches you a little bit about how to get started with app development. If you pair that with a curriculum like Apple's free Everyone Can Code curriculum, and in particular the app development with Swift books from the bookstore, you'll go a long way towards becoming a real app developer. All right, enough of the plugs over. What we're going to do, though, is get back to Swift Playgrounds and our augmented reality playground and see where we're at. So let's skip over to the iPad. If you remember, we talked about this developer app. Here it is again. You can see that you can browse, you can set some favorites, you can look at different collections. You'll also be able to read all about the Swift Student Challenge winners. None from the Code Hub, unfortunately, but maybe next year you guys will submit a few things to the Swift Student Challenge. Really impressive stuff, though, from these students. So, all right, that's sort of what we're going to aspire to. That's what's coming next week as well. WWDC is coming next week, so we'll see a lot of new sessions. Let's open up Swift Playgrounds and get back to augmented reality. So if you recall, we went through, first we learned about what is augmented reality. We were able to use this one function call to build an augmented reality scene. So we can say, let's run our code. Here we go, we've got the camera view. I've already said that I'll allow this playground to use the camera. I can tap anywhere to place it. Those little dots are looking at feature points in my environment. So when I tap, I've now placed the lemon floating in midair, as you do. And when I start the scene, it rotates and drops fall, and you can see that the drops are falling, and it looks like they're splattering against the horizontal plane that it detected down there. So very cool little effect. Oh, and then it's gone. And if you're playing this at home, you're going to hear sound. I have the sound turned off just for all of our sanity. But if you're playing this at home, you'll hear the sounds that they authored to go with these playgrounds as well. So that's what we did. We changed this from do something whimsical to do something friendly. There was also do something mysterious. And then we moved on to adding a model. And this is where we were playing around with yesterday. And this might remind you a little bit of the lights, camera, code playgrounds that we played around with, where we have, instead of a space, we have a scene this time. And what we did yesterday was we created a traffic cone model. We actually defined it as a type because we were playing around with assigning a different value to this variable. And we assigned this traffic cone model a model.trafficCone. Just like this flying bug model, we assign a model.flyingBug. Here we have a nice little comment telling us what to do. So we add our models to the scene. So we add both the traffic cone model and the flying bug model. We have this onStart handler, which gets invoked when we press that start scene button that we saw. And all we do here is we just use the default animate methods on each one of our models. So let's run this to remind ourselves what this looks like. Here we go. We've detected the planes again and the feature points. I've got my traffic cone as the first thing up because that's the first thing I added. We can tap here to place it. So now it's placed it on the surface. Kind of cool. And now I can place my flying bug. We're going to place it here on the corner. And now that I've added all my models to the scene, I have an option to start the scene. I can also tap on those objects to reposition it. Now there's a lot of code, and we talked a little bit about the amount of code involved here to build this interface. Let's start the scene. So there's our traffic cone. Our flying bug is just floating up and down. Our traffic cone still loses its edge a little bit. Maybe it's disappearing through the desk. So not bad. Those are our two models. Now there were a lot of other models that we can add. So we could add a snail. We could add a ton of different ones. Now we learned a bit about, we learned a lot of Swift that we can use to add multiple things to our user interface. Now what I could do is I could say, all right, well, let's give ourselves a little bit of space here. We're going to create another variable. We'll call it next model because I can't remember which ones there, what ones are there. We'll say model dot, and now we have all of our options here. You see there are a lot that this artist has drawn just for this playground. Let's try adding a cactus. We'll go add it to the scene now. So scene.add. And we're going to add our next model. We could even try doing this. Let's try doing this. Let's try adding, so scene dot, and let's add something that we already have. So maybe we'll try to see if we can add 2 copies of the flying bug model. So we'll add flying bug model again. And then let's animate our next model. So our cactus will animate. So there's some other options here that we're going to explore a little bit. There are different animations that we can add, but we're just going to use the default animation. So let's hit run my code. All right, we've detected the desk. So we're going to place our traffic cone. We're going to place our flying bug. We're going to place our funky looking cactus. And then now I've got to replace my flying bug. Okay, so it's not adding 2 copies. It's just replacing the one when I call this add scene.add over here. So now if I start the scene, you can see they all animate at the same time. You remember when we were in Reality Composer, we were trying to animate certain things and our animations were happening. One would start and then complete, and then the next one would start. Obviously they've fixed that. They've addressed that problem here. So this animate method is actually all 3 of these are able to animate at the same time. And imagine I want to play with all those different models that we have on the model class, the model type. I don't really want to have to, this is getting very repetitive where we do scene, add, scene, add. What if we create an array of models and then we loop through that array to add them all to the traffic cone. And then the same thing inside the scene on start handler. We loop through that array and we animate all of our models. Let's try that out. So the nice thing is yesterday we figured out that the base class for these models is imaginary node. And we figured that out. We kind of cheated. We figured it out. It's not really cheating, but we figured it out by going scene dot add, and we can see the signature here is it's looking for this object that's an imaginary node. And since we can add both a flying bug model, a cactus model, and a traffic cone model using this method, we know that they're all of type imaginary node. So that's what's going to be held inside of our array. So let's start here. We're going to create a variable. And we're going to call this models because it's going to hold all the models that we want to add to the scene. And what we're going to do is we're going to define the type. So we're going to use the colon, which is over the K. We could also hit the 1, 2, 3 button down here to go find the colon. Give it a space. And now what this is going to be is this is going to be an imaginary node. Actually, remember, this is going to be an array, right? So first we need our square brackets. And then inside the square brackets is going to be that imaginary node type. And we'll start off with an empty array. So let's bring the keyboard back up. We need to get the square brackets, so I'm going to hit the 1, 2, 3 button. We don't see any square brackets there. So what we're going to do is we're going to tap on the hashtag plus equals sign. And now we've got our square brackets. And it auto completes it for me. So now I've got an empty array called models. Now we want to add all these models to our array. I'd be inclined to look for something where I could actually get a hold of all those different types of models. Let's have a look. We'll say models dot append. And now we have to append something. So let's start with a model dot alarm clock. Now this part here, actually, and what we'll do is we'll delete these. So let's select, I'm going to select this whole bunch of text here where I create my traffic cone model property, my flying bug model, and my next model. I'm going to delete those. It's going to cause some errors down the line. But that's all right. We'll deal with those in a sec. For now, what we're doing is we're just building our array of models that we can add to the scene. So let's test this out. We'll add one more here to our models array. Append, and then it's a function, so we're going to use the parentheses, and we're going to pick a model. We're going to use the autocomplete model dot. Let's use arrow. Let's just go through them alphabetically. So right now we have 2 items in our models array, an alarm clock and an arrow. Let's add those models to the scene. So what we're going to do is erase all of this stuff. So we'll select it and drag and delete all of that. You can also just hit the delete key over and over again. Did you remember how to loop through an array? So we use a for loop. And it's actually a for each loop because we're going to be going through each item in an array. So we'll just say for model in models. There, autocomplete's helping us out. What this line will do is it'll say, okay, cool. So for every single item I have in this models array, I'm going to loop through, pull it out, and let you run. I'm going to assign it to this model variable, and you'll be able to play around with it. And then when you're done with it, we'll go back up to the top and grab the next thing out of the array and play around with that. So let's add the braces for our code in here. So for each model in the models, we want to add it to the scene. So we'll go hit scene in the autocomplete bar. Scene dot. We're going to add it to the scene. So we'll do add model. And that's it. Now, instead of having to type scene.add twice for both my alarm clock and my arrow, I've only had to do it once inside this loop. And I have 3 errors right here. If we tap on the red dot, we can see this error, use of unresolved identifier traffic cone model. And we've seen this one before. It's just kind of a fancy way of saying Swift doesn't know anything about it. We haven't defined it anywhere, because we used to have it defined and then we took it away. So let's delete that. In fact, let's delete all of this. Okay, now we have to remove next model as well. And the way we would animate each one of those items in our models array would be the same way we add it to the scene. So let's create a for loop. For model in models. So the same thing, we're going to get to this on start handler. So when someone presses that start scene button, we're going to fall into this code here. And we're going to say, oh, cool. All right, I have to loop through all the models that I have in my array. And I'm going to do something with them. So what I'll do is model dot autocomplete tells me that the model has an animate method, so I can call that, or disappear, or location. So let's use the animate method. Now you notice for the flying bug, there was a specific flying bug animation type that we could use in a special version of this method. That doesn't exist on Imaginary Node because it's a fairly generic way of referring to all these different models. Like when we talk about, you know, when we talked about types, we talked a little bit about how an animal is a superclass, and then a dog is a specific type of animal, and a cat is a specific type of animal. And the more specific you get, the more methods you can have on that particular animal. So maybe a dog could have a go for a walk method, whereas a cat is not going to have that method. So you couldn't call go for a walk on animal, or it wouldn't make a lot of sense to call go for a walk on an animal, because that's not going to do anything when you try to tell a cat go for a walk. Let's run our code and see what happens with this, with our two models that we've added to our array. Maybe that animal's analogy didn't stick. All right, so we're gonna place our alarm clock there. Now I've got our arrow. Let's add our arrow over here. Cool. It knows that we've placed all the models that we have. We can tap on them again to reposition them. Let's start our scene. Cool, so that's behaving just like it did before. So now, instead of having to change this code down here and add another scene.add for each model we add, now we could go through and say, okay, well, let's append another model to this array. So we'll do models.append And remember, append just means we're adding an element to the end of the array. So whatever we're storing in that array, we're just adding another one to the end. So we'll add model dot. Let's see, let's just pick the next one here. Well, we've done cactus, so let's do ear. Let's do another one, models dot append. We'll do the next one, so model dot. Let's add some lightning. How about that? So now if we run our code, I've only added 2 lines of code for 2 models. We've detected our surface. We're going to drop our alarm clock, drop our arrow. We'll try to drop them all nearby. There's our ear, and then there's our lightning. So we've added everything. We start the scene. Kind of cool, not bad. Now, the only problem we might have with this is if we add too many models to this particular array, it might get kind of long and boring for the person using this next to add all these models to the scene. But we can play around with that a little bit. All right, so those are our models. We've added a few models to the scene. We've played around with our for loops on arrays. Let's go on to the next page and see what's going on that page. So we're going to use actions to control our models. And if we tap on action, because it's in blue, it just tells us it's a simple reusable animation that changes the attributes of any model you attach it to. Okay, and here's an example. So we have a rain cloud, and we can attach an action by using this .run method. And this particular action is .move to snail location, and it's going to take 4 seconds. Okay. So maybe what we'll do is we'll actually try running that same exact code. So it says first we want to enter the model that we want to run an action on. So like the rain cloud in this case. Then we call that run method and pass in the action by typing a period and selecting one of the options. So we'll have a few options other than just move to. So they're asking us to use an action to move the rain cloud to the location of the snail. All right. Then we can try out other actions such as rotate or scale to get a sense of how they work. Let's try it. So here we have 2 variables, rain cloud and snail. They're both taken from that model.raincloud and model.snail. This is kind of interesting because they can add an array of items to the scene by using the square brackets around their 2 variables. That actually might be a better way of doing it than we were doing it before on the previous page. This is a handy new method where we can add an array of things. Then we have the scene set on start handler. And let's see, they pass in a raincloud.animate and they pass in a .rain parameter. So let's add the action. I guess we'll see. Let's see what it looks like without adding anything. All right, so it detects the surface. We'll drop the rain cloud there. We'll put the snail over here. If we start the scene, okay, there's the rain animation. That's cool. Now let's try using this move action and adding it to the rain cloud. So what we're going to do is we're going to type in rain. We're going to start typing in rain cloud. There goes my autocomplete. I'll hit rain cloud dot. Now we don't want to do animate. We want to do this one here, run. And if we look, there's actually a group of actions that we can run, or a sequence. Well, I guess we'll find out what that is in a second. But let's try this first one here, this run action. And the parameter name is action. So let's see. The action that we're going to perform is, they said to enter a dot. So we can either do a fade to, move by, move to, rotate by, or scale to. So we want to move it to the location of the snail. So let's hit move to. Now, just like in the Lights Camera Code playgrounds, we can get locations of things and move things. And there's that grid paradigm, right? So let's get the snail dot location. And we'll take 3 seconds to get over there. So let's try running this now. All right, we've detected the table. I'm going to drop the rain cloud way over here. And we'll put the snail over here. Okay, and if we start the scene, it starts raining. And the cloud stops moving. So that was an animation because we could watch it slowly going over to the snail. So we can watch it animate over to the location of the snail. And it says here, notice that one action, move by, takes the values for X, Y, and Z. It's right, I said Z, not Z. Because we're working in three-dimensional space. Just like we were with Reality Composer. And this is a handy way, and it's even worth taking a screenshot of this. So when we adjust X, it moves objects left to right, Y moves objects up and down, and Z moves objects forward and back. So next, on the next page, we're going to learn about distance events, but we're not going to do that yet. We're going to play around with some of these other actions. So let's try a different action. So we use .move to. We're going to delete that. I just selected and hit delete. Now I've got a problem. I need to grab more of this code and delete it. So we're going to delete all of this. And now what we're going to do, we could do fade to. We could do move by. We could just move it a little bit. We can rotate it by. And again, look at this. We have our X, Y, and Z and the duration it takes. So when we're dealing with animations, we always want to give it a certain amount of time that we want the animation to happen over. And we can have it scale to. Well, let's try scale to. So we'll say, let's say 5 will be our number. That's not a number. That's an equal sign. And we'll have it happen over 4 seconds. That's also not a number. I gotta stop dragging down. Okay, there's 4. I'll hit run. And we'll detect our rain cloud. Now, we don't really mind where we put the snail because it's not related to the snail anymore. When we start the scene, we can see our rain cloud grow quite a bit. Now, maybe we don't want to go that way, because if you look outside right now, it's actually a bit cloudy. Maybe we want to say, do you know what? I don't want the clouds to scale any bigger. So let's actually make it a bit smaller. Because this is a float, we can use a decimal number, so we'll actually make it quite a bit smaller. But let's have it run. So we're going to have it scale down to 0.2 of the size it is now. Let's run another animation. So raincloud.run, and we're going to use the dot to get a built-in action. And let's have it fade as well. So we're going to have it fade to, this is a float, so we're going to do 0.2. And we'll have it do this over 8 seconds. So this one will take a little bit longer, double the time of this one. So in 4 seconds, it'll shrink down. And then by the time 8 seconds is up, it should have faded to 0.2. Now, I'm not 100% sure, but I believe this is on a scale from 0.0 to 1.0. So if you fade it to 1.0, it won't fade at all. It'll be just as bright as it normally would be. When you fade it to 0.0, it would actually disappear. So let's try running our code to see. We can play around with that. All right, we've detected our plane. We'll drop the cloud there. That's the only one we really care about. We'll drop the snail there. Start our scene. There it goes. It shrinks and it fades away. I like that we can kind of control the weather and have it disappear, well, completely, it seems. Well, nope, not completely. There it is. You can see just the hint of it. So that's fading to 0.2. If we try out our little hypothesis that it's from 0.0 to 1.0, let's try that by changing our fade to action. We're going to place the cloud there, place the snail over there, start the scene. There it goes. And you can see that our fade actually didn't do anything, right? It didn't fade at all. I just like that it's a much smaller cloud. And the snail probably does too. All right, so we've got two different animations there. We've got scale 2 and fade 2. We can see that they're happening again at the same time. It's scaling and fading at the same time. Let's change this back to 0.3 maybe, so it does stick around a little longer. Let's add one last action here. So let's do rain cloud, dot, run. We'll pick dot to find one of the built-in ones. Let's do rotate by. So we won't have it, well, let's have it rotate on the x-axis. Oops, that's not a number again. I'm struggling with numbers today. We won't have it rotate on the y-axis. And then forward, we'll have it rotate 180. And we'll have that happen over 4 seconds as well. Now, if we wanted to get fancy and we wanted it to keep rotating, we might put this in a while loop and just have it run forever while true, and then have it keep rotating. Maybe we can experiment with that a little bit. So there we go. There's our snail. We can start our scene. Okay, maybe that's a bit too fast, that rotation. And now we've got our rain falling up. So that's cool. We're playing all sorts of tricks with our physics now. Now, of course, the rain cloud isn't the only thing that we can add actions to. We can also add actions to our snail. So let's try that. If we do snail dot, it's also going to have this run method on it. And if we say dot, we also have these same built-in animations: fade to, move by, move to, rotate by. Let's use the move by. And we'll just have them shuffle over a little bit so that it doesn't get wet. So we won't have them go up at all, because snails can't fly. Sorry. And we'll have them move. They're kind of slow, so let's have that happen over a long period of time. So now we've got our rain cloud animations. We've got 3 of them. And then we've got 1 of the snail animations. So let's place our cloud here. We're going to place our snail over here. Start our scene. Well, our snail actually shot way away. Let's try this. Let's have the snail move away from us. Place our rain cloud, place our snail, start the scene. You know, it's a pretty fast snail. So maybe what we did was 50 is far too large a distance for that snail to travel over 20 seconds. So maybe what we need to do is give it something a little bit less. So instead of 50, what we'll do is we'll just do 5. Let's run our code. Detect our surfaces again. Tap to place it. Tap the snail, place it here. And we're going to start the scene. That's a little better. Now we can see that 5 is still pretty far. So maybe what we want to do is use those floating point numbers a little bit more and instead say something like 1.5. Because you can see the snail is way out there, somewhere in the trees, right there. So those are worth playing around with. Those built-in animations are pretty cool. This syntax is a little bit different, the way we call this function here. But it's one of the powerful aspects of Swift that you'll get into if you do move on to something like app development with Swift. There's a whole chapter dedicated to this type of function here. And it comes in really handy when we're dealing with animations and we want to have something happen over a longer period of time. And then we also want to be able to customize it so that people can pass in different things that'll happen over longer periods of time. So that's all we'll cover for today. We've got more to go through here with our augmented reality playground. We'll come back to that tomorrow. Hopefully you've enjoyed that today. I would go around and play around with our adding a model. Maybe append some more models to your models array, add them to the scene, place them all around, build something interesting up. Maybe try to tell a story with some of these animated models that are provided to us. All right, hope you enjoyed that. We'll see you guys again tomorrow. And until then, happy coding.